Welcome to qnawire.
Hi, so over here we're going to compare the attractive force in between, first of all, potassium and the bromine ions, and on the second option, we're going to compare it with manganese to plus and oxygen to minus ions. So in this case, for both of them, what is going to happen is that they're going to obey Coulomb's law, which tells us that the force is going to be equal to Coulomb's constant times charge 1, charge 2 divided by the distance in between them squared. So for the first system, the distance in between both of the ions is going to be equal to 342 picometers, and on the second case, the distance is going to be of 273 picometers. Useful information is going to be that the elementary charge of an electron is going to be equal to 1.602 times 10 to the minus 19 coulombs. That 1 picometer is going to be equal to 10 to the minus 12 meters. And finally, that Coulomb's constant is going to be equal to 9 times 10 to the 9 Newton meter squared over Coulomb squared. So for the first system, the value of the force in between both of these ions, remember that the positive and negative charge of each of them corresponds to having plus the charge of the electron and minus the charge of the electron, respectively. So what is going to occur is that the force is going to be equal to our Coulomb constant, 9 times 10 to the 9 Newton meter squared over Coulomb squared, multiplied by charge 1, corresponds to 1.602 times 10 to the minus 19 coulombs, multiplied by the second charge, which is going to be the same value but with a negative sign. In this case, we're just going to compare the magnitude. So if we want the magnitude of the force, we simply need to add the magnitude of the individual charges. So this becomes 1.602 times 10 to the minus 19 squared over the distance in between these two ions, which is going to be 342 picometers. But we cannot square picometers directly, we need to convert them before, as 1 picometer is going to be equal to 1 times 10 to the minus 12 meters. And all of this quantity is the one that we can square. So the magnitude of the force in case A is going to be equal to 1.9748 times 10 to the minus 9 coulombs. Sorry, newtons. This would be the magnitude of the force for the first system. Now, for the second system, the charges are going to change a little bit. We're going to have a larger charge. We're going to have a value equal to 2 for each of them. So for system B, the force corresponds to Coulomb's constant times 2 times the charge of the electron corresponding to manganese, and the same value over here corresponding to the minus 2 over the distance of 273 picometers, with the same consideration as I mentioned before. And all of this is squared. So with this, the force is going to be equal to 1.24 times 10 to the minus 8 newtons. As you can see, this is going to be one order of magnitude larger. So the force in between manganese and oxygen is going to be larger than that coming from potassium and the bromine ion. And with that, it would be all. Thank you very much and have a good one.